So this is my negotiated project 1. I'm just going to show you everything works first of all, and then we'll go through some code a bit later. So let me just launch it. Okay, so first thing you'll notice, I've integrated Steam. I got bored one night and just did that. Shows you Steam stuff up here. So the first thing is the queue system that I use for switching between the main menus. So like it goes through the league pages that uses a queue system. This is the settings menu. This uses the queue system to go in, but once you're on it, it uses stack system to load up these like sub menus. I called them. So I've got a few different changing things. So you can save your crosshair, you can change your sensitivity, you can change some graphics settings, and obviously audio. Um, if you head back to this page, so we have the store page, this uses maps to make the objects, and then once the player selects them, they disappear. Obviously, that would simulate a buying process in a real game. We then have the battle pass system, which is like an unlock system for when you level up, and then obviously it allows you to highlight over them, have a look at all of them before you equip them. So let's throw on this one here. If we head back, we have the league table. This is obviously would be connected to a server somewhere, but instead we use data tables to get all the data. So this one uses binary search and in ordered search. So if you search a name, so let's say Nathan, it shows you score and the name of him. And obviously if you wanted someone else, but you want to search by the score, let's say 198, we'll get Paisley, and that will do all of that. And then after that, we have got the actual in-game stuff. At the moment, it's just obviously representing your gun, your sensitivity, your crosshair. It's got a firing system and a score saving system for when I add targets to it, and then it's going to save back to the binary tree, which stores all the scores. So this is the queue. Um, Basically, there's a function that sets up the viewport ready for menus to be made. This is the show top UI that is called every time a new UI is added to queue and then wants to be popped to the top. Um, there's obviously the add to queue function, which just adds the widget to the queue. It's pretty simple. There's also removing the top widget from the queue, so it pops it off, and then obviously the one underneath gets displayed. Obviously that's why it runs the show top UI after it. These are all the functions that you can call to enable each one separately, and then there's a clear all UI for where you want to deload the scene. And obviously on the begin play, we're just making some variables with the widgets that we've made. So the next thing we're looking at is like the linked list battle pass system that I made. So obviously linked lists are non-STL, so obviously you have to go and make your own class for them. My one's holding an F battle pass data struct, which obviously holds image name if it's unlocked and the gun texture, and then obviously the nodes being created here, and finally the like linked list which connects all the nodes created. So in that there are several functions, including an add node one for inserting data, an insert at the beginning if you ever needed to insert data at the beginning, a delete at position to delete certain nodes if you ever needed to delete the data out, and a get position function which gets the position through a search of the name of which one you're looking for. So obviously if you need to do that, that's there. Obviously it's then linked up using the uLinkList class that I made into the battle pass function. So how it works is there's a bigger menu, and each gun slash texture is its own unique widget, and it obviously it has to go and insert that. So that's why we have to create the templates and checking if like the scroll box is there. Obviously I've added some like feedback, so hovering over the texture and obviously changing the texture and unhovering the texture. I had to make a little system for that just so the user gets some feedback. I made it loop a little bit to get a bit of animation and fade in. Um, this basically makes each one and then reads all the data off of it and changes the item to that. Uh, that's pretty much it for the linked list class. The next thing I'm looking at is the binary tree slash scoreboard system that I made. So obviously for this one I needed to save scoreboard data, which is obviously the name, the score, and the position they're at. Uh, Obviously I also had to set up a single each like node for the binary tree, and that is also done in the binary tree node header file. Obviously, then we've got the binary tree class, which is the big long one. So, obviously, there's function to insert data. I'll make this a little bit bigger. Insert data into the system, obviously, because it has to be ordered. Because it's a binary tree, it has to go through and do all the checks, obviously doing recursive loops until it finds the correct position. I've made a function for in-order traversal, so obviously it goes from lowest to highest. I also made one for reverse order traversal, so it goes highest to lowest, because obviously scoreboards go high to low. Um, there's obviously the ordered search, so this doesn't use binary search, it just uses ordered search. So this is when you insert the name, it will do a search for the name, because the actual binary tree is ordered by the score instead of the name. Obviously, you can do it by name, it will just be done via the alphabet. I did it via the score. Obviously, we then have the binary search function, so obviously it's when you insert the score and it will return the name to you. Um, this is all controlled in the scoreboard manager. So in the scoreboard manager, obviously, instead of accessing like a server, I'm just using a local data table, which just holds obviously the name and score. We're reading this and then inserting it into the binary tree. Um, Obviously, it's using the same system of creating lots of little widgets on the screen. So obviously it goes through and makes 100 of them, adds the name and the score here. Obviously then I've got an overloaded function just because it's more efficient. You can insert either an int or a string and it will search that, and then obviously the results will be handled by the results handler, which literally just changes the text on screen. Um, Obviously there's an initialization of the search because I need to check, is it a number or is it a, a word, and it's basically just checking if it's numeric or not and then running the correct function off that. And then obviously on the begin data it's just importing the data table and then assigning it to the binary tree. So the next one we're covering is like the stack or like the submenu system in the video graphics and audio settings. So obviously it's non-STL, so I had to go through and make all the functionality myself, which is pretty simple on the scale of things compared to a binary tree. Um, so I use templates in this one, so any variable data type can be used with this. Um, yeah, so obviously there's the push functionality, which adds it to the stack. Obviously there is the pop functionality that removes it from the stack, and then yeah, there's a check if it's empty or not, if you ever need to make sure before accessing it to stop getting like crashes and null pointers. And then obviously there is the peek functionality, which will return the data from the top element in the stack to read. Obviously then I implemented it into the settings menu. So here you can see I'm using my stack class and I've got it as set as user widget because it is using user widgets like on-screen displays. Obviously saves them all as variables. And then if we have a look at the functions over here, so obviously there is literally a function to display the top screen, um, which is literally just like it looks at the top of the stack and then we'll display it and add it to the viewport. There's a remove one, so it will peek at the top of the stack, it will then remove it from the viewport and then obviously pop it off. There is adding to the stack, so obviously if you need to add something to the stack, it will push it on and then it will display the top screen after that. And then obviously the settings menu, it's just a function that returns to the settings menu because it has to transfer between the queue of all of the menus and the stack that is the submenu system. Um, it's very efficient and I'm surprised no one uses it. So obviously an important part of my research was the testing methodologies of it. So I used white box testing, which basically for me was unit testing. This was important to prove that my queue, my stack, and my binary tree all work because they were obviously my data classes that I made. Obviously, I can show you the test functionality working now, and if I stop there, this is all the tests that I did for it, all coming back successful. I can also show you some of the code now. So obviously all of my unit tests are done through C++, and basically they go through and test all of the functionality that I built into my binary trees. in order traversal, reverse order traversal, and then obviously everything to do with my linked list. So inserting data at the start, deleting certain positions, getting positions, obviously stack pushes, pops, empty, and stack peeking, all using unit testing.